Hi. So in today's stream, we are going to be recording the content for part 22, where I'll be working on creating the rest of the enemy stats. So the article is already out on the blog, which you can find. Well, you can go to blog.terrascore.com to find the article. So we are going to be fleshing out the rest of the enemy stats for today, and that will be for part 22, and then that will prepare us for the next part, which is to create a buff and debuff system for the enemies and the players. So I realized that if we do not have a buff and debuff system, then there are some weapons that we just can't create. So for example, like there is this freezing weapon in Vampire Survivors. It's called something Lancet, I think. And we can't create that because there's no buffs and debuffs. And can't we also cannot implement the knockback that the garlic has. So if you hit an enemy with the garlic, for example, the their knockback multiplier is increased, but you can't do that as well. So today we're gonna implement that, and then in the next part we're gonna implement buffs and debuffs so that you can actually see that in action. And that will give us a very robust enemy system and a weapon system. And from there we can see how we can move on with the series. So hi Kaya, nice to see you. Thanks for tuning in. I actually forgot to set up my stream, so I'm just gonna get all my different screens up first. So I jumped in, I went live, and then I forgot to set up the stream. Just give me a moment here to get everything up. Here, Visual Studio. Oh, wrong screen. Visual Studio. Where is Visual Studio? This is Edge. Microsoft Edge is here. And Visual Studio is here. So let's get started. Okay, so just to provide some context as to what I'm talking about. If you look at our enemies after we finish part 20, right, the enemy spawning system is fantastic. You know, you get a bunch of mobs and you get different spawns and stuff, which I'm very happy about. And I've also added sounds. I've created a new video. We've released a new video last week as well, talking about how to add sound effects to your weapons. So now we have sounds in our project files, and we have enemies and stuff. And we also, after 30 seconds, I think, we get mobs that spawn. So we've created a mob that basically is a swarm of enemies, and then we've created also flower walls. See the swarm of enemies here. So we've created a bunch of mobs, and you know, you have different mobs that spawn and everything, which is pretty cool. So in terms of the enemy spawning system, you know, we've got something very nice going on here. And what I want to do now is to, if you look at our enemies, right, the stats. Wait, this is the new system, right? Okay, I'm gonna have to roll back a little bit further, I guess. Just give me a moment there. I rolled back to the wrong version. Let me start from here instead. And okay, so let's look at so what I was talking about is, if you look at our enemy prefabs, right? The enemy stats, well, they're not set up in a very ideal way because we just have current move speed, current health, current damage. So in the last part, we removed the enemy's dependency on enemy scriptable objects, right? Because anyway, these enemies are prefabbed, so we can already store the stats. But by just storing the stats in this way, it makes it very difficult for us to apply buffs and debuffs, we also haven't implemented all of the stats that the enemies have. So if you look at the Vampire Survivors wiki, you will see that enemies have a couple of stats. They have a health, they have power, power is just damage, and they have speed, and they have knockback. They have knockback stat, which controls how much knockback they receive, and they also have an experience stat, which, well, the experience stat, we've already implemented it in the drop rate manager, but so we don't have to implement the experience stat, but we do have to implement the knockback stat, and then we also have a bunch of resistances like this. We have freeze, we have kill resistance, we have debuff resistance, and we have a couple of things as well, like we have a HP boost, and then we have curse as well. Okay, so the fixed direction and the floaty, we are implementing it by changing the enemy movement script, but then there are still some stats that we want to implement. And the other thing that we want to do as well is, if you look at the player character, recall that we have a base stats and actual stats. And the actual stats, well, it's not supposed to be adjusted by us, so this technically should be hidden. So if you make this private, it'll be a good thing. I just made it public when I was creating the player stats because I wanted a way for us to check to see, you know, what the player's actual stats was. Okay, but well, you can make this private, it's fine. So why do we have two stats? Why do we create two stats for the player character? It's because the base stats are there so that we can calculate the actual stats. And for the player character, right, why do we need two stats? Because we have a set of stats. Well, the player stats are boosted by passives, right? So if you get passive items, you will boost the stat. So for example, let's say you get armor, this will boost your armor stat. If you get a clover, this will boost your luck stat, and so on. So because there is a need for us to record stat boosts, we record a set of base stats so that we always know what values to revert to. So let's say if we remove the passives, then the stats will revert back to the base stats, right? So if you recall in player stats, back all the way back in part 15, right? Player stats script, we've created a new function called calculate stats. And this is what helps us to recalculate the stats every time we receive a new passive item. See that? So then this allows us to not just add passive items, because when you add passive items, you add stats, right? But because you have a record of the base stats, right? Whenever you remove the passive item, this will allow us to revert back to the original set of stats. So let's say if I have 5 passives, then this will take into account all 5 passives, and from there it will calculate the actual stats of the player. So now in the next frame, if I remove, let's say 2 passives, then this script, if we call this script, it will take the base stats again, but it will only take the 3 remaining passives as into account, and then calculate the stats for us. So then by recording the base stats, we have a system that allows us to track whatever stats that we have, and this builds into the buff and debuff system as well, because like passives, right, buffs and debuffs are meant to be added and removed, right? So for that reason, our current enemy setup cannot work, because they do not store 2 sets of stats, they only store a single set, and it's not all grouped together, which makes it a little hard to manage. So what I'm gonna do is, for the enemies, I'm gonna set up a structure that is similar to the player like this, where you have the base stats and the actual stats. And then once that's done, this will allow us a lot more room to implement modifiers like curse, or modifiers like some enemies, their HP increases as you level up. It's called HP times level in the Vampire Survivors wiki. So then this allows us to implement stuff like this. So what we ended up with in the last stream was pretty cool, so I can't wait to show you what I have in store. Hi JT. Thanks for tuning in. And Sean, if you want to super chat me, you can, but if you're my student, I wouldn't feel very good about taking your money, because, you know, students are broke. And I'm still working, so if you're working and you want a super chat, I'll be happy to take it. But if you're a student, then keep the money for yourself. Go and buy yourself a nice cup of Starbucks or something. Okay, so let me just set up my phone, because the entire part over here is pretty disjointed. So I just want to give myself a script of sorts. So I've explained why we want to reorganize the enemy stats script, right? It's so that it makes the whole thing easy to manage. So what you see here is, let me just refer to the article here. So what we want to do instead is to build something like this, where you have the base stats and then you have the actual stats. And then notice that there are a couple more stats that are inside there. So we're going to build something similar in the enemy stats, which means that we will have to go to the enemy stats script and add a bunch of new structs. Okay, so let's have a look at the code over here. Let me just zoom in. So we want to go to the enemy stats here and then just add two new structs over here. So we have a struct for resistances, and then we have a struct for stats. And what we want to do is to build a new stats object here, like two objects, one base stats and then one actual stats. And then this will give us the new component. Okay, I will go through what these new components do in a while. So let me just show you how the new component looks like first. So when we grab the new enemy stats script over here, we will also have to make a couple of changes to our codes, because previously our move speed stat was given by current move speed, right? But then now it's changed. So when we do that, we will have to, okay, so in the code that I've just shown you just now, what we have here is we have base stats, we have actual stats, and these are based on the stats struct that we have. And I've also created, this is what is called a getter, and this basically gives us the actual stats. Because the actual stats itself, the value here is private, so then we are not able to access it from other scripts. So then this actual getter allows us to access the actual stats. So what this allows us to do is, this allows the other scripts to modify the, it doesn't allow the other scripts to modify the actual stats, but it allows it to only retrieve the value of the actual stats. And let me just update the movement scripts first, and I'm going to show you what's changed about the enemy stats script. So if you grab the script from us, you will also have to go back to your enemy movement script and then make sure that you change this to actual. So now it's enemy.actual.moveSpeed. And you want to update this in your enemy movement script as well as the charging enemy movement script. So this again becomes enemy.actual.moveSpeed. What I also like to do, right, is, well, in the enemy stats, I've also renamed one of the variables over here. Sorry, not enemy stats, enemy movement. The enemy movement, I've renamed one of the variables here, and that variable that I renamed is this enemy stats. So I prefer to call it stats because we are already in enemy movement, right? So that tells us that we are really dealing with something that the enemy has. Stats tells you more about the enemy you are modifying. So it's up to you if you want to change this. I just thought that, you know, changing this just makes a little bit more sense, and I'm a little bit of a stickler for using the right vocabulary, using the most descriptive words to describe our scripts. And if you remember, if you checked out our previous part, I talked about self-documentation, right? How you want to make every script that you have as self-documenting as possible. What this means is that your scripts, when I take a look at the script, either the script itself or the component, the naming of the variables and functions should tell you about what the script does. That is the ideal, which is why I'm so particular about the names. So what I've done here is I've just changed the reference to the move speed because it's now retrieved in a different way. Now the move speed is packed inside a data structure, so then we will need to retrieve the value from the data structure itself. You will find these changes documented inside here in the blog as well. So you're just changing the current move speed to accessing the stats.actual.movespeed value instead. And the same thing for the charging enemy movement, you change this to this. And these changes allow us to see the new enemy stats, which I think are pretty cool. So now you have resistances that you can set, and then you have, of course, different health stats and speed stats, and we also have an extra knockback multiplier stat. Where is it now? Which is right here. So then this allows us, of course, to go to the flower wall, and the flower is hard knockback, right, the game, so you can reduce the knockback multiplier, and this will slow the amount of pushback that the flower receives. For the melee slash, yours is slower even though the value is set to the fastest. Like, it is not snappy. So Sean, I think you're referring to the melee attack that you showed me in class yesterday, right? For that one, it's because your animation has to be faster. So you can just try and increase the frame rate of your attack. Another option that you have is, see, instead of using the, just give me a moment. Instead of using the, why can't I go into my own channel? I'm showing you a YouTube video that I wanna. Okay, so instead of using your current sword slash attack, you can actually look at, we have some VFX tutorials, and then you can just check out the whip tutorial. So what this does is, if I'm not wrong, your slash effect now is animated using sprites, right? Why don't you just try using a particle effect to animate it instead? And then it's easier to set the animation to be faster. Actually, it's not easier, but I prefer using particle effects because that saves me the work of creating a new animator and all that. So you can check this out and see whether this helps you. Okay, so let me run through the code, the changes to the enemy stats script. Okay, so the main changes are basically adding two data structures over here so that I can create a new variable called stats. The type is stats. So I'm creating a new stats, and this is called base stats. I'm creating another stats object, and it's called actual stats. And the stats object itself just contains max health, most speed, damage, knockback multiplier. It also contains a resistances object. And this resistances object is a other data type. This should be a struct as well, actually. But you know what, whether it's a class or a struct, it doesn't really matter that much. Or does it? Let me think. Maybe this should be changed to a struct. This makes more sense. Let me just update that. So this should be a struct. Okay, there we go. So we're creating two new data structures, the resistances data structure and the stats data structure. This allows us to create two variables that are stats, and we have base stats here and then actual stats here. And then this, of course, allows us to set up a structure like this. So when you create a base stats and you go back to Unity, you will see the base stats object is dropped down like this that has all these different stats. And if you want to delve even deeper, you can actually click on this here and then go to debug. And this will actually show you not just the base stats, but the actual stats. The reason why the actual stats is hidden and private is because the actual stats are calculated in the game. So when you are setting the values for the enemies, the actual stats itself doesn't have to have values. That's why it's hidden. So the actual stats value is only valuable for us when we are debugging the stats system that we have. And in the next part, if we are doing the buff and debuff system, to check if the buffs and debuffs actually work, we will have to check out the actual stats of the enemy, not the base stats. And so once we create these structures, we create a getter called actual so that we can retrieve the actual stats. This is for the other scripts that refer to the values that are inside enemy stats. For example, our enemy movement script, which we have just modified. Because we need to retrieve the move speed from the actual stats, we will have to create a getter like this that gives us the actual stats, because otherwise the actual stats object is private and we can't access it from other scripts. We keep the current health, or rather we create a new current health variable as well that replaces the old current health stat. So the current health is important because we only get to set the max health. The current health will always be equals to the max health. And we remove a couple of variables. One of the variables we remove besides the old stats is the player variable because it's not used. So I don't know why it was there, but because it was not used, I removed it as well. And yeah, so then we remove the line that sets the player as well again because it is not used. And we call this function called recalculate stats, very similar to the player stats function called recalculate stats, and then we also set the current health to the max health. So then recalculate stats for now just sets the actual stats to the base stats, but in future what's going to happen is that we are also going to add, well, it's not in the future actually, it's just later on in the parts. In this part, we're also going to add some formulas inside here because don't forget that we have the curse effect. So then we're going to take into account the curse effect to modify the actual stats of the enemy based on the base stats, of course. And that's really all the changes. Okay, we also did a small optimization on the collision stay to the function. The reason why we did it is because previously, right, when there is a collision with our enemy, we will check whether the other object that we are colliding with is tagged player, and then if it is, then we will find the player stats component and deal damage to the player. But well, you know, there's actually a much shorter way to do it that doesn't involve tags. Personally, I don't like to use tags because tags add a lot of work. So for example, if you need your tags to work, you have to always remember to add the player tag to all your player characters. And you know, like when you use tags for a lot of if you use tags a lot to identify different enemies, then it's just gonna make the entire management of your different prefabs or game objects, it's gonna make it very complicated. So instead of using tags, what I like to do is I like to just check for a component. So I like to just check for, over here I'm using try get component. This checks if the colliding object has a player stats component. If it has, then right away this value p, because over here this is called an out variable. What this means is that if you put this value here, then this function, if it finds a player stats object, is going to assign it to p, and then this p can be used to take damage, to deal damage to the player. So this makes our code a lot shorter, which is why I prefer to use this structure instead of using this structure. And this also has the added benefit of not needing us to use tags to identify the player character. So that about wraps it up for the changes to the enemy stats object. And once we are done, right, once we have all these stats over here, you want to spend some time to go to all your prefabs and make sure that you set the stats values accordingly, because of the change in the data structures, right, you're gonna lose your stats that you've previously set based on the old system. So you have to just run through all your prefabs and then reset all the stats again. It's very important. Okay, once you otherwise your enemies won't have health and they're not gonna be able to move very well as well. So it's not the best thing. So once that is done, oh yeah, one more thing I forgot to mention actually is that when we updated the take damage, okay, so previously we used the current damage value, and now we are changing this to actual damage because again, we are changing the way that the stats are stored. So then the variables that refer to our different stats have to change. So now that we are done here, let's look at the next part. So once we are done here, let's implement our stats, because there are a couple of stats that are unimplemented. So we have the knockback multiplier here, which is unimplemented. We also have the freeze stat and the debuff stat, which is unimplemented. The problem with this is that we don't have a freeze effect and we don't have a debuff effect as well, because we need a buff and debuff system for that, right? So we only have a way to implement the kill resistance. So we're going to implement a knockback multiplier, the knockback resistance first, and then we're going to implement the kill resistance. And then after that, we will do a couple of things to circumvent some scenarios that you might have found in part 20 of our series. Or is it part 20? Sorry, part 21 of our series, not part 20. Part 21 is when we do the enemy spawning, right? Okay, so let's look at our knockback stat again. So technically, well, if we want to keep things simple, right, we only have to implement it's not even one line of code, it's just we have to multiply the knockback by the knockback multiplier here, and this will actually fix, or rather implement the knockback multiplier stat into our game. But you know, because we are building this tutorial, right, so that most of you who are watching here, if you followed this far, you probably want to build your own game, right? Either for a school project or just a personal passion project. So what we're gonna do is add a little more complexity to our enemy movement component. So I want you to be able to customize the way that your enemies are knocked back as well. So when you knock an enemy back, notice that you're able to set both the velocity and the duration of the knockback. So what I'm gonna do here is to multiply. I want to be able to multiply both the velocity and the duration of the multiplier. The problem is that if I multiply this twice, then you're gonna get 4 times the effect. When you, so for example, if I do a knockback multiplier 1.5, instead of getting a knockback multiplier 1.5, you're gonna get a knockback multiplier of 2.25, because 1.5 times 1.5, right? Because you are multiplying this value twice, you're increasing the velocity and the duration. But this is a problem that we'll tackle later. Okay, so in the code that I will be showing you later, we are also introducing a new variable here called knockback variance that allows you to set whether the knockback multiplier will affect the velocity, the duration, or both. Or if you don't want your enemy to be knocked back at all, you can just set the knockback variance to nothing. And this will make the enemy immune to knockbacks. So then you have a couple of options here with how you want your enemies to be knocked back. For some enemies, you may want to shorten the knockback duration only. For some enemies, you may want to shorten the knockback force, the velocity. And for some enemies, you may want to shorten both. So if we want the enemies to be knocked back by both the velocity and the duration, then we will also have to reduce the amount of the knockback that we are getting. So let me just explain to you what I mean. So let's say if we have a, how do I explain this? Let me try and use paint to explain this. So the amount of knockback that you get, right? Let's say we have a bad guy over here. Let's paint this guy red. Let's say we have a bad guy over here, okay, and then we have a knockback effect on it. So how far the bad guy travels after getting knocked back is based on 2 things. The first thing is the velocity, or the force of the knockback. That's the first factor that will affect how far it travels. Second is the duration of knockback. So because of these 2 things, if you adjust either of these 2 things, it will affect the distance of the knockback, because the distance that you're knocked back essentially is determined by velocity times duration, right? So when you want to reduce the knockback, you can either reduce the velocity, or you can reduce the duration, or you can reduce both. So if our multiplier is 0.5, right? So let's say the knockback multiplier here is 0.5. Then what this means is that I want to halve the distance that the player travels. So if the knockback used to be, let's say, this arrow's distance, I want to reduce the knockback's distance to this. For me to be able to reduce this, I only have to multiply the multiplier by either one of these values. So I want to put a multiplier of 0.5 either to velocity or to knockback. If I put it onto both, right, what I'll get is I will get double the effect. So if I multiply both by 0.5, then basically I'll get a 25% reduction instead of a 50% reduction, because 0.5 times 0.5 is 0.25, right? Let me just write that down. 0.5 times 0.5 will give you 0.25. So if I'm halving both the velocity and the duration, then my final travel distance will be 25% of the original value. And that is not what I want, because then what is the point of the knockback multiplier if it's not accurate, right? I want it to be accurate. So this means that if I want to have a knockback multiplier of 0.5, but I also want to affect both the velocity and the duration of the knockback, I will have to do something. Okay, so let's talk about some basic math over here. So I want, when I multiply both values, I want to find a value where if I multiply this value to both the velocity and the duration, this will give me exactly half of the distance. And the way I get this is by using square root. So if I do a square root of 0.5, then well, this value is about 0.707. And this value here, right, if I multiply it to both here and here, then I will get a distance reduction of 0.5. Why is that the case? Because, well, again, it's basic math. So if I take the square root of 0.5 and I multiply it by the square root of 0.5, this will actually give me it gives me 0.5, right? So this is why when I multiply the square root by to both the velocity and the duration, this gives me back 0.5, and then this reduces the travel distance by exactly 50%. It's a little bit of math. So you just have to be able to play around with figures and have a basic understanding of how algebra works to work this out. But if you don't understand this, it's fine, as long as you understand the idea behind us having to reduce the knockback multiplier. That's important, because otherwise we are not going to get a multiplier that reflects the actual knockback that the enemies receive. We want our numbers to be as accurate as possible, because once you start squaring values, then you get the effect gets exponentially bigger the smaller your knockback multiplier is. So if it is 0.1, for example, then the knockback multiplier will actually become 0.01 because you multiply it twice, and then that will just have a, I mean, if you see something on the screen that doesn't reflect the values that you put in, well, obviously it's a bug, right? And you don't want to have bugs in your system. So that is what I'm doing here. I'm creating a way for you to control what kind of knockback you want to have, and then also doing some math to make sure that no matter what option you select, you will always get the same knockback amount that you set your knockback multiplier to. So we're gonna grab the enemy movement script, and then I'm just gonna run through with you what's going on over here. So knockback variance over here is a enumeration. It's also a flag, which gives us the option of selecting any one of these options. Okay, so we only have velocity and duration inside the flags here, and then we also have nothing. Okay, if you don't want either velocity or duration, you can select multiple options over here. We have a rigid body. I'll explain why later. We added a rigid body, and this knockback variance here is used to create a new variable, and the default value is velocity, meaning that by default, if you knock back an enemy, it's just gonna slow the velocity but keep the duration of the knockback. And we assign the rigid body component over here. This is because we are going to use it later. In the knockback function, this is where the main changes occur. So instead of setting knockback velocity and duration just to the velocity and duration that we have here, this is covered in part 14. How knockback is implemented is covered in part 14. So here we're just expanding on the feature a little bit. And what I'm doing here then is that I'm setting this power to 1. The reason why I'm setting power to 1 is because we are using square root. And square root, essentially, if I want to take a square root of a number x, a square root of a number x is equivalent to x to the power of half. That is why we are doing this, because, well, you can't, if you are working with code, there oftentimes you have a square root function, but you're not going to have a cube root function, or if you want to root to the power of 4 to the power of 5 and all that stuff, you're not going to have that. So whenever you want to do, for example, operations like x, and you want to root to the power of 4, then you would do x, and this would be 1 over 4. This is why the variable here is called power. So power of 1 means just, well, it's just the same value. But here we are checking if our flags here, it reduces velocity or it reduces duration. This is called a bitwise operator, and, well, I guess I have to cover what a bitwise operator is as well, right? Which I'm dreading quite a little bit. So this, if you recall, this knockback variance data type is actually a flag. And what a flag is essentially, well, a flag is just, it's a bunch of booleans. So if I have, for example, if you look at the layers in Unity, these are all flags. Okay, flags allow us to at times assign multiple values to one single option. So if you go back to say our item data, for example, okay, and you go to evolution data, you are able to select, multiple values over here. These are called flags, and flags basically operate by using, well, flags, because flags are essentially just a bunch of zeros and ones, and you can think of them as a bunch of booleans as well. What are booleans? Booleans are true or false values. So you can think of them as having 32 flags. Are basically a series of 32 zeros, and you can set any one of them to 1. And they are used for different purposes. So they are very efficient ways to store booleans, because again, booleans are true or false values. They are very efficient for storing booleans because you take 4 bytes of space and you can store 32 of them. As opposed to if you store regular boolean, you'll find booleans are basically, these are booleans, all right, true and false values. So if you use a single variable for a boolean, then it's quite a waste of space because you have 1 byte for the boolean. But then if you're storing the booleans in the flag, then you have, well, you have 1 byte here, so this is total of 4 bytes. For 4 bytes, you can store 32 booleans. And what we are doing here is in our flags here, we only have 2 possible values, which means that our flag here only has these possible combinations: 0, 0, 0, 1, 1, 0, or 1, 1, which corresponds, right? Because what we have here is that we are able to actually only select either duration, velocity, or both, or neither. So then we have these 4 possible values. The nothing and everything are just shortcuts that Unity adds for us, but the real values are duration and velocity over here. So when we do this is called a bitwise AND operation. My code over here, where is it? My code over here is called bitwise AND operation. What this is basically, if I have a set of flags over here. So for example, I want to enable velocity and I want to disable duration. So then if I want to check whether velocity is enabled, I will check like this. And what this bitwise AND is basically, bitwise AND means that if both values are 1, then I'll get a 1. So the solution to this operation here, this is called a bitwise AND operation, is as follows. Like this. Because over here, the 2 values here are 1, so then this gives me a 1. Whereas if I have, let's say if my flags are set like that, then this will give me 1 and 0, which will give me 0. Because 1 and 0 gives 0. 0 and 1 also gives 0. So this will give me 0. So then I want to check if these two, this column of numbers here, if both of them are 1s. Because if both of them are 1s, then this gives me a 1. And then this will give me a value that is greater than 0. So why do we have a greater than 0 check over here? The reason is because this whole thing is actually a number. Alright, because if you have numbers in code, the code is usually stored in binary. So these 32 flags over here, right? Every possible configuration of the flags over here corresponds to a certain number. So for example, if my flags are 1 on the last 2 values, then this is actually a value of 0, 1, 2, 3. So this is actually a value of 3. Alright, again, this has to do with binary counting. So how computers count is 0 is 0, 1 is 1, 2 is that, and then 3 is like this, and then 4 is, and then 5 is 101, and 6 is 110, and so on. So then what we have here is these flags also correspond to a number, so every number will actually give us a specific combination of our flags. So then if we do an AND operation, because whenever we check for one single value here, right, the single value is always going to be something like this. So it's either it's all zeros and there's a 1 somewhere. Okay, so this 1 is just in like a different place every time, and then to check different flags. And then once we get 2 1s, then we will get a 1 here. So because of that, if we do a bitwise AND operation and we get a value that's more than 0, then we can be sure that the flag is turned on. So then we are here checking whether the velocity flag is turned on, and for the other one, we are checking the duration flag is turned on. So then we are converting these to booleans so that we can check if reduces velocity and reduces duration is on. And over here, what I'm doing here is once I'm getting the value, Let me see if I can get this to scroll, but actually it's fine. So then once I'm getting the value here, let me just copy this into Visual Studio. Just show it here. So once I check the values of whether velocity and duration are activated, I will check if both of these values over here. So if the knockback multiplier value is approximately equals to 0 or equals to 1. Sorry, if the value is approximately not equals to 0 and it's approximately equals to 1, and if both these values here, if we are both reducing velocity and duration, we will want the power to be 0.5. Again, 0.5 is half. So if you take something to the power of 0.5, it's the square root. And this, recall how we talked about we have to square root the value if we are going to be multiplying by both velocity and force. So then here we set the power to 0.5 because later we will square root the knockback multiplier. This is only done in a certain circumstance. And the circumstance is as follows. We want the square root to only occur if the value is not equals to 0, because if the value is equals to 0, well, you cannot square root 0. Right? Does it make sense to square root 0? And well, the value has to be 1, because if the value is not 1, then the power here is not 0.5. I think maybe there's a code error here. Why is there a 1 over there? Shouldn't be a 1, right? Oh, sorry. Yeah. I understand the math now. Okay. The reason that we cannot have a 0 is because we cannot square root 0. And the reason that we have a 1 here, why we are checking if the value is equals to 1. This should be not equals to 1. I'm sorry. Missed out some logic here. It's not equals to 0, not equals to 1, because you can't square root 0. And if you square root 1, it's just going to get you 1. Okay, so then there's no point for us to modify the power value if the value of the multiplier is 1. So we're just avoiding certain values to square root because, well, you can't square root certain values. That's why. And let me just update the code over here as well. So this should be, it's not equals to 0 and not equals to 1. There we go. Okay, let's go back to where we left off. Which is here. So if we're applying the effect to both the velocity and the duration, we want to square root the value. It's power of 0.5 square root, because 0.5 is 1 over 2. And then I want to make sure that the value that we are applying a power to is not equal to 0, because 0 cannot be square rooted. And 1, if you square root 1, you get 1. So then you don't want to waste the computing power on that. So let me just double check. Square root of 0. You can't do a square root of 0, right? So the square root of 0 is 0. So it makes sense, right? 0 times 0 is 0. Okay, it makes sense. So we're just avoiding these values. Just maybe it's not needed. Can simplify the code here actually. Yeah, you know what? We can simplify the code over here. Let's just remove this. Yeah, so usually I won't simplify the code because, well, I can understand the code, right? But over here, I think because if you're watching my tutorial, you're trying to learn. And when you're trying to learn, I don't want to make things harder for you by complicating the code wherever it's not necessary. So the original copy of this code was actually more complicated, and I made it simpler just so that it wouldn't be difficult to understand what's going on. So let me just modify this part and remove checks. Okay, the checks are pretty unnecessary. Let's remove that. If we square root 1, we'll get 1 back, right? Yeah, there we go. Just want to make sure that my math is right. Okay, so here, if we are both reducing velocity and duration, then we will want to get this to the power 0.5 because we are multiplying both the velocity and the duration with the knockback multiplier. Yeah, so then this power, if it's 1, if this value remains 1, this means that only one of these is activated, and if only one of these is activated, then this power here will be 1, so the multiplier will be 1. And the other thing that I want to bring your attention to is that we have this little thing called a ternary operator here as well. What this ternary operator does is that only if reduces velocity is active, then you will get the value here, and then you will set this to the power here. And then otherwise, you will get the value to be 1. So if the value is 1, means velocity times 1, which keeps the velocity the same. And if reduces duration is not active, same thing, duration times 1 will give you back duration. Okay, so if velocity is reduced, then of course you will take the knockback multiplier and multiply it and raise it to the power of whatever we set. Again, because it's only 1 or 0.5, you will get either 1 here, which is the same value, or you will get 0.5 here, which is, well, a reduced value. So with that, I've explained everything that there is to explain in the knockback function. Okay, again, this is made a little bit more complicated just to give you more control over the options that you have. So now if you go over to your enemies, you realize that you will have a lot more control over the kind of knockback that you want your enemies to have under the enemy movement. So you can have knockback variance here, and then you can control whether it's velocity, duration, or both. Or you can have no knockback at all, which means that this enemy becomes immune to knockback. So if I have a knockback multiplier of, let's say, 0.1, if you can test this out, or let me set this to 0.1, then the knockback variance here, let's say, is just velocity. What this does is that it makes the flower extremely hard to knock back, and it only knocks back 10% of the usual distance. So let me just drag a flower onto the scene, and you can see how difficult it is to knock back a flower enemy. See that? It's barely getting knocked back. Even though the bats get knocked back quite a little bit, but the flower doesn't. Let me just try this again with a different weapon just so that you can see and visualize this. I'm gonna use a knife. Let me get a knife. And let me just drop a flower onto the scene. There we go. So let me just try and strike the flower over here. And you see the knockback is really very little, just because the velocity is reduced. Okay, I'm going to show you another example, but with duration now. So if I set knockback to duration, you will see that now the knockback effect, it just happens over a way shorter amount of time, but the speed is the same. Okay, let me just drag a flower onto the scene, and we will see the effect. The bat is pushing. The bats are so annoying. Try putting another flower on the scene here. See that? So now you see the knockback is a lot less. It's just a very short time that it happens over. So these are two ways that you can modify knockback, and you can see also if I try to have a knockback variance of everything, which is duration and velocity, you will see again this whole thing will behave in a different manner. You will see a little bit of the duration reduced and a little bit of the knockback force reduced as well. Okay, so you'll see you can see a visible change. And one thing that we have to fix later is notice that the flower here is getting pushed by the bats. So we have to deal with that later. But after making all these changes, you being able to control how much knockback an enemy has gives you a lot more leeway to play around with in terms of how you can tune your enemies to be either more difficult to kill or more easy to kill and avoid. And the last thing that we are modifying in the enemy movement script is actually the, let me just scroll down here. It's actually the move function. So here in the move function, previously we only had one way of moving the enemy, and that is that we are adjusting the position directly. This is not the best thing to do, because if you have a rigid body on your enemy, it's always better to use rigid body move position to move the enemy around, because if you move the enemy, the rigid body doesn't update, so then there may be some collision glitches that may happen. So wherever you have a rigid body, it's always best to move the enemy's position using rb.move position as opposed to using transform.position. This is the only change that I made, and there's a comment here that explains why this change is made as well. And this is the reason why we added a rigid body. Well, it's not to control the rigid body, it's to check if there is a rigid body. Because in the start function, right, if we run this piece of code and then there is no rigid body on the enemy, then this will just give you an empty object, because this will be empty. And then when you get to the move function over here, this will fail because there is no rigid body, and then we will just try and move the position of the object. So only if a rigid body exists, then we will try to move the rigid body instead of moving the position directly. It's minor optimization to the game, but it's a good thing, because Unity always tells you, if you read the documentation, it always tells you whenever you have a rigid body, you want to do a move position instead of a transform position. So now that we have implemented knockback, the updates to the move function I explained over here, and you can also test out the knockback multiplier. If you apply it to the flower, as if you've played the game before, you will find that the flower is very hard to hit, to push away, right? So with the new knockback multiplier feature, you will find that you can implement the same features into your enemies as well, okay, to your flowers as well. And once that is done, you will find that next thing you want to do is to fix collision jankiness. What do I mean by that? Okay, so just now you saw that the flowers, we can push the flower around, right? The bat can push the flower around. You've seen this a couple of times just now. So that is something that you want to fix. And the other thing that I want to fix as well is you will find that enemies are blocked by the environment like this. So for example, here I have a swarm of bats flying, and then you will see this is a square block, and then the square block is just straight up blocking some of the bats, and they're just not being able to move. And the other thing as well is that you will find this pretty funny situation where you have a flower wall and the flower wall is there, right? And they're blocking the bats. So the mobs are just trying to rush through, but because the space is too small, not all of them are able to get through. So we wanna implement a couple of changes to our mobs so that these kinds of situations doesn't happen. The easiest way to do this is actually to make my mobs kinematic, which means that I just have to go to my mobs over here and just change the rigid body from dynamic to kinematic. What kinematic does is that we have an article that explains all of this. What kinematic does is that basically it makes a rigid body, right, it makes a rigid body have a, how do I explain this? It makes a rigid body not be affected by collisions. It can push things, but it cannot be pushed. Let me repeat this again, alright? So if I make something a kinematic, this means that the body can push other objects, but it cannot be pushed by itself. So for example, the flying enemies, right? You want the flying enemies to not have their collisions be impeded by environmental objects. So then what a kinematic rigid body does is that if a rigid body is kinematic, it's not gonna consider other objects in its way. It's just gonna fly through collisions, and anything that is in its way that is not kinematic will be affected by it. So then if you have an environmental object, because the environmental object is immovable, and then the bats, because they're kinematic, now their movement cannot be stopped. You will see the bats will just fly through the boxes. So we want to change the mobs to be kinematic, and we also, if you don't want the flower wall enemy to block other enemies, you can also make the flower wall kinematic. If you make the flower wall enemy kinematic, this will allow other enemies to pass through the flower wall, but it will not allow the player to pass through the flower wall. This is because the player is a rigid body that is dynamic. So kinematic objects only block dynamic objects. They do not block other kinematic objects. So by having the flower wall be a kinematic, this will prevent other enemies from pushing it around also. So right now I'm just gonna change the flower to a kinematic object, and then let me just put a flower onto the seed. You will realize that the flower wall can no longer be pushed. See that? It will just ignore the enemy. So it still blocks the player, it just doesn't block other enemies. And you will see the bat mob has the same thing now. So if I put a bat here, it's just gonna be able to fly through the environment. Yeah, see that? Just because it is now a kinematic. So kinematic objects are pretty cool. And by setting certain of your game objects to kinematic strategically, right, this will allow you to circumvent a lot of the junkiness that you will find, like for example the flower wall getting pushed, or the flower wall, or the bats being blocked by the flower wall, or the bats being blocked by the environment objects. So think about what objects you want to set to kinematic. Basically, when something is kinematic, they are not affected by collision. They will just fly through everything, or everything that is hitting them will ignore them. So this is pretty cool. So what I've done is I've made the bats all kinematic, because then they act like flying objects, can fly over everything. And the flower wall is just done this way so that it cannot be pushed. Okay, so this is the first method you can think about if you want to fix jankiness or janky movement characteristics in enemies. Second thing that you can consider is that you can look at the colliders of all your enemies and environment objects, and you can change the colliders from a square to a circle. The reason for this is as follows. Alright, so for example, my zombie mob, I still want my zombies to be affected by collision, because it doesn't make sense for them to ignore colliding with everything because they're on the ground. For the bats, it makes sense for them because, well, bats, they fly, right? So it makes sense if they fly over something. But for the zombie, I'm not gonna change the zombie to a kinematic. This is because I want the zombie to... Can the zombie walk faster? It's walking so slowly. This is because I want the zombie to... Let me just try this again. Let me just increase the speed of the zombie, and then place the zombie mob. Okay, let me try this again. This is because I want the zombie to be blocked by objects. See that? I want the zombie to be blocked like this. I don't want the zombie to be able to just fly over objects. So then for other situations where you have the environment objects blocking the, let's say, your zombies, you are still gonna get some issues if you have a mob of them and they're all stuck behind, let's say, a plant or a rock. And how you can fix this is by looking at all your game objects and making sure that their colliders are circular. Because if their colliders are circular, it's much harder to clip on them. Okay, so just now I showed you an example of a zombie getting stuck on a square collider object. So right now, if I were to go to my rock here, right, and let's say if I change the rock, the collider, let me change this collider from a circle to from a box collider to a circle collider. And let me just show this to you here. I'm going to move this up. So now I have a circle collider, right? And let's say the radius is, I can just keep the radius as it is, right? So if a circle collider, I'm going to just move my character under the rock, and I'm going to put a zombie above the circle collider. You will find that the zombie has an easier way finding its way around the circle collider, just because the circle collider doesn't block you in the right angle. So let me show this to you. See that the zombie has an easier time going around as opposed to if we have a square collider. If we have a square collider, it's going to be harder for the zombie to find its way around. So you want to make sure that all your objects are changed to a circle collider like this. Then this will make collision much easier to handle, much less clipping. The third thing that you can consider is you can go to the layer collision matrix, and then you can just think about what layers you want to assign your enemies to. So for example, you may want to have flying enemies and grounded enemies, and you may want to set the layer collision matrix to be as follows. So let's say flying enemies do not collide with grounded enemies, and flying enemies do not collide with other flying enemies. Though you want to make sure that you do not disable the collision with the default layer, because that is where our player is in. So if you disable the collision with default layer, then what's going to happen is that you will find that your players will not be damaged by enemies while flying as well. So you want to be extremely careful with using the collision matrix. If you want to find that, it's inside Edit, Project Settings, and under Physics 2D. You will find all the checkboxes here. And the more layers you add, the more checkboxes you will have. And this is just a pretty cool and pretty easy way to control which layers, which category of objects collide with one another and which categories don't. Personally, I don't use the layer collision matrix, because I find that just being able to set something in kinematic for the most part is enough for me. So in future, we may have to use this, but for now, I'm not using this. But if you want to use this, just be my guest. It's a pretty powerful way to control behaviors in a very specific way. So we have a couple more things we want to implement. We want to implement Q resistance and want to implement curse. Okay, Q resistance is pretty easy to implement. Okay, it's just a very small change inside the player stats, sorry, the enemy stats script. And all you want to do is just go to take damage function over here. And we want to be very specific with the way that we implement the Q resistance. And the reason for that is because, let's just go to the script first. The reason for that is because we don't want everything to trigger Q resistance. So let's say if I have very weak enemies, let's say we have the bat, and the bat has like 5 health, and then you have a whip that does maybe 7 damage. If you have a scenario like this where you have a weapon that deals more damage than your enemies, then every enemy, when they get hit, is gonna trigger Q resistance. So what you want to do is that you want to only check. So under take damage over here, right? If you want to implement Q resistance, you just have to go to take damage and just modify the way that take damage works. And what take damage does is that now instead of dealing the damage, and then after that just moving on, we will deal the damage and we will see whether the damage is equals exactly to the enemy's max health. If it is, then we will check whether, I think the code here has some problems, actually. Okay, the code here, okay, something really silly here. So I deal damage first, then I check whether the damage is dealt. So this shouldn't be like this. I should be moving this somewhere else, right? Otherwise, it doesn't make sense. So let me just modify that as well. Where is enemy stats? Okay, there we go. So what I'm saying is that we just have to move things around a little bit. Okay, there we go. This is the damage function. And the highlighted portion has to be actually, it has to be above the part that deals damage. So before the damage is dealt, there we go. So let's highlight this whole part here. So if you look at the function and how it's modified, this actually makes sense. So the modification is inside the take damage function, and you'll see take damage What the function does is it just deals damage, and it basically checks whether you need to do a floating text and then apply knockback. So all the things that happen when an enemy takes damage is baked into the take damage function, right? So Q resistance, right, it's gonna be over here as well. And what triggers Q resistance is, if you look at Vampire Survivors, right, some weapons that will deal exactly the amount of damage that the enemy has in health. So for example, if the enemy's health is 5 and let's say the pentagram, if the pentagram activates, then it's gonna kill the enemies that are around, right? So pentagram, in the edited video, we're gonna show you well, how it looks like in the game if you don't know how it looks like. But when an instant kill weapon triggers, it's just gonna deal damage equals to the max health of the enemy. So here, when we have take damage, we check whether the damage is equals exactly to the max health of the enemy. If it is, then we will ignore the damage. This is if we have enough Q resistance. Okay, so how does the logic of this works is we have this random dot value over here, and this will give us a value between 0 to 1. And then we also have an actual stats, Q resistance. So if you recall, Q resistance is a value also from 0 to 1. So if the Q resistance here is, let's say, 0.5, you will see that you have about 50% chance to survive instant kill attacks, and if your Q resistance is 1, you'll always survive instant kill attacks. So then this random value here gives us a value between 0 to 1 as well. So if my Q resistance is, let's say, 0.1, this means that I have a 10% chance of getting a number below 0.1, which means I have a 10% chance of surviving. And this is how this is done. So again, take note, you only want to have the Q resistance, do a check of whether you should survive the attack if the damage is equals exactly to the maximum health. If it's not, then you will want to ignore this effect. And the reason for this is because otherwise you will have a lot of weapons triggering this, because there are a lot of weapons that do more damage than the enemy's health. And I've just captured one problem here with the code, and that is that instead of using damage, instead of comparing the values like that, I should actually use mathf.approximate. Because otherwise, when we are comparing floats, when we use the equal sign, it doesn't always work properly. This is because floating point numbers are, by their very nature, imprecise. So it's better to use an approximately value over here. And so Q resistance is pretty simple to implement. Yeah, it's just a little chunk of code inside take damage that you have to implement, and that fixes the issue. Okay, and then the rest of the code is just the same. So let me just grab this piece of code and put it into the project. And the next thing we want to do also is to implement two things, the curse boost and the level boost. And this is where things get pretty interesting. So before we start doing this, right, I'm gonna do a thing where I maintain parity with the player stats. What do I mean by that? So the player stats actually has a actual variable like that. Okay, and what this does is that this gives us the player stats actually has a stats variable that gives us the value of the actual stats. And what I'm gonna do is to add one more variable here called actual. And what this does for us is that this allows us to, because if you look at the enemy stats object, you use stats.actual to retrieve the value. And as far as possible, we want the coding conventions to be the same across scripts, because otherwise it gets confusing. If I want to retrieve the player stats, I have to use the stats. So I have to do something like player.stats to get the player stats, but if I want to get the enemy stats, I have to do enemy.stats. Sorry, enemies.actual, enemy.actual. So there is a disparity over here because it's the same kind of data that you're retrieving, but the variable is different. So what I'm doing here is I'm just adding a little new getter so that you can use either stats or actual to retrieve the player stats, and this will give us some level of parity. So now when I want to retrieve the player stats, you can just do player.actual like this. So then there is a similarity between how the player and enemy works, which is always a good thing. So here we just have multiple ways to retrieve the player stats, because both the actual variable and the stats variable return us the same value. Yeah, so this is what I mean by just maintaining parity between the two scripts over here. Okay, this is not very important, but it's something that you might want to add. It doesn't change the way your code works. It just gives you more ways to use your own code. Once that is done, we will have to modify the game manager to track all the players. Okay, so if you look at the game manager script now, it only tracks a single player. Only tracks a single player, and the single player that's tracked is right here. And what we want to do is just change things around. Firstly, we are tracking the player using game object, which is not the best way to do it. Because if I want to get the player stats, I would have to get component and find the player stats, right? That's one thing. The other thing is that, well, if I have multiple players, then I have a problem as well, because how do I track all the players that I have? So to this end, we will make a couple of changes to the game manager script. Okay, we will remove the player object over here, and then we will replace this with a player stats array called players. This will allow us to store and track all players, and store and track all players by the player stats variable. So it's a lot easier for us to retrieve their stats. So I'm just going to replace this with public. No, this doesn't have to be public. Just player stats. Okay. And of course, this player stats object is private because you don't need to manage it, so it shouldn't be shown to the user. Second thing is that in the awake function, you want to, of course, just find objects, note the S here, find objects of type, just to retrieve all the players in the game. So players, find objects of type. Just replace that. So by finding all the players, what this allows me to do is to create a new function. And this new function is called get cumulative curves. Because every player has a curve stat, right? Does it make sense? So then we just want to have the total curve stat. Let me just see how this is written over here. Okay, so over here we have total curves. This is the total value of the curves that all players have, and we want to just add all the curve stats of all the players together. And then once that is done, notice here I have a 1 plus total curves. This is because the default curves value is 1, which means that it's times 1, right? You can't have the cumulative curves be below 1. The reason it cannot be below 1 is because if it's below 1, then you will reduce the stats of the enemy. Doesn't make sense. Alright, so if it's below 1, we're gonna have return 1 over here. And here we just add all the curve stats together. And let me just copy and paste this function. Okay, there are a couple of changes we want to make to this actually. It's actually best if we add a new just mathf dot math 1. Okay, so what I'm doing here is, let me just update this function and I'll explain what's going on here. So here we have get cumulative curves, right? Where is it? Where is it? Okay, there we go. Here I'm gonna add a mathf. Sorry, 1 and then just the 1 total curves. And for the total level, it's gonna be the same thing. I'm gonna do mathf max 1 here. And let me explain what's going on here, because this is gonna be pretty important. Okay, so over here, what's going on is that we want to add all the curve stats of all the players together. But there may be it's possible for the curve values. Okay, if the total curve ends up being to be less than 1, because you know you can mess with the curve value in the player stats, right? So if the total curve value is less than 1, what we're gonna do is that we are setting a limit to the minimum value of the curves. So if 1 plus total curse, right, if this is negative, for example, if total curse here, for some reason you manage to get it to be a value that is below 0, so let's say 1 plus minus 0.5, this will give us 0.5. So if this curse value is less than 0, right, it will cause problems because it actually weakens enemies. And we don't want the curse value to be less than 1. So here we are just doing a mathf.max and then 1 plus total curse. And what this does is that this prevents our curse value from falling below the value of 1. We're doing the same thing with the level because we also want the level to not fall below a value of 1. Because otherwise what this does is that this will cause the, because this is a multiplier, right? So this will cause some problems because if the level, cumulative level is 0, right? And something times 0, this will give us value of 0, and then if you multiply this with any value, it will give you 0, which is not a problem that we want to run into, which is why we set these limitations. Okay, so what these two things do is they just add up all your curse stats or add up all your levels. And the reason I have this error here is because under player stats, I didn't add the actual variable over here. So this should be public character data dot stats actual, then this should be get return actual stats. There we go. Okay, so now that we have all of this implemented, you will find that it's possible for you to retrieve the cumulative curse stats from the game manager. And we also have to, because we replace the player object variable, right, we will also have to update our scripts. Okay, so in the game manager over here, besides adding these functions, we will have to remove this player object script over here. Let's go all the way down to find the kill function. So because the player object is no longer there, we cannot run this piece of code anymore. Now what we have to do is we have to just look through all the players. So this will be for each player stats, p in players, and then we just do p send message. Okay, because we have to apply this to all the players. And this is the change that we have over here. Okay, instead of killing one player, you have to kill all the players when the time is up. And this will fix the error that we have over here, assuming the changes are saved. Maybe it's not saved. Let's try this again. Player object does not exist in current context. Okay, so here we have one more part here that I have to change as well, because this refers to the player object as well. So same thing for each player stats, p in players, p send message, apply and remove this. Oh, it's remove and apply upgrades. I'm sorry. So again, all of this is documented in the article, so you can just check out the script. So we're almost done here. So now that we have a way to retrieve all the curse values and all the level values, we have to tally the boosts. And this means that we have to go back to enemy stats and make some modifications to it again. And okay, so here let me just explain what's going on, right? So in enemy stats, again, we have a bunch of changes. And if you remember this over here, this is just modifying how the operators work on our structs. Okay, so we have one multiplier operator for the resistances, and we have one multiplier for the maybe the resistances shouldn't be multiplied directly, huh? Doesn't make any sense. Because if we do that, then we have to make sure that the value maxes out at 1. Okay, let me just make some minor changes over here as well. So for the resistances, I want to change the way that the resistances work. And the reason for that is because I don't want it to be increased beyond the value of 1. So whatever value is multiplied here, instead of doing this, I will have to do r.freeze times factor. And then I'll have to make sure that this is mathf.min. Minimum here is, I don't want it to be more than 1, right? So this should be minimum of 1. Oh, sorry, I got the code wrong. This should be minimum. This shouldn't be maximum. And same thing over here, this should be minimum, not maximum. So we want to make sure that the value is always either 1 or less. So this would be mathf.minimum 1 rq factor. Same thing here, this should be mathf minimum factor. This should be r.debuff factor. Just fixing some minor bugs with the stats. Okay, let me just re-record this part over here where I explain the cumulative values, right? So we added 2 new functions. We add 2 new functions to our game manager, and the reason for that is because we want to calculate the cumulative curse stat as well as the cumulative level stat. And here we in the cumulative curse stat, we just have a total curse local variable over here, and then we just loop through the entirety of the players. And then after that, we total up the curse stat from all of the players. And then here we are doing a mathf.minimum, and this is because we want our curse value to always be at least 1. So if the wait, this is, I'm so sorry, this is max. This is not minimum. Having a bit of a brain fart over here. My logic was correct. So if you're editing the video, just ignore this part. Ignore my edits to this part previously, because the mathf.max is the correct function. Okay, so let's go back to the mathf.min here that we implemented. Okay, so what I want to do here is I've implemented a multiplication operator. This allows us to multiply the resistance by a number. Okay, so for example, I can increase the freeze resistance from, let's say, 0.3 all the way to 0.6. And what I'm doing here is I'm just grabbing the freeze or the kill or whatever, and then I'm multiplying it by the number over here. And this will allow us to very easily multiply resistances, so that you can see over here I can just take the resistance and multiply it by a certain number. And this is only possible if I have the operator function above, right here. And what I'm doing here is, on top of just getting the value and increasing it by a factor, I'm also checking to make sure that the value is never more than 1. Alright, so if this freeze, let's say I have 60% freeze resistance and I'm boosting it 2 times. So this will be 60 times 2, right? This will give me 120% or 1.2. 1.2 is larger than 1. So then if this value becomes larger than 1, it will just set the value to 1, because it doesn't make sense for your resistance to be more than 100%, right? Because 100% means that you are just blocking the effect entirely. So it makes no reason, there's no reason for you to have a resistance of more than 1. Or does it? Actually, we can have a freeze resistance of more than 1, right? If that happens, it just means that you heal from, let's say you have freeze and then you have resistance of more than 1, you just heal from it. Does it make sense? Okay, we'll just keep this cap, but you can choose if you want to remove or keep this, depending on whether you feel that it makes sense for your resistance to be more than 100%. I don't think it makes sense on removing this, but there are games where it's possible for you to have resistance that's more than 100%. So it's up to you how you want to implement this, whether you want to just remove the math.minimum here, or you want to just limit it to a maximum value. So then when I have this, what I'm also adding to the stat struct over here is a boostable enumeration. This is again, these are flags. And then I have two boostable here in curse boost and level boost. And then after that, this is basically a static function that it's a private static function. So what this is, to understand what's happening here, you have to understand the operators for multiplication. And for this is I'm using a different operator because we can't use multiplication for both. So then for curse, if I want to increase the stats for curse, I'll use times. If I want to increase the stats by using level boost, I will use this symbol over here. And no matter what symbol I use, okay, you will notice that I call the boost function over here, and the boost function just takes a stat and it multiplies it by a factor. See that? Multiplies it by a factor. Except for the knockback multiplier, because the knockback multiplier will be divided. Because for the knockback multiplier, it's the opposite direction, right? The lower the value, the better it is. Higher the value, the weaker it is. Okay, because higher the value means more knockback. Greater knockback is always advantageous to the player. Okay, so for knockback, because you want it to work in reverse, you will use division. And resistances, again, you multiply. And again, this is made possible only because over here, we have an operator that defines how the multiplication operator works with the resistance struct. Yeah, so this boostable over here, right? This basically is a flag. So let me just copy it and paste the code into my script and show you what I mean. So by making these changes, sorry, this is the wrong change, because I pasted the script to the player stats. Let me paste them into the enemy stats, and I'll show you how this pans out. All the errors here should be fixed now. Now reference, I can just clear this, no problem. So if I go to the enemy over here now, so on top of having all the stats that you can adjust, you will also find an additional setting over here. Okay, so in the stats itself, you will find not just resistances, but you will find the ability for you to modify what the curse stat boosts. So by default in Vampire Survivors, the curse stat will boost health and move speed. And then the level, you can make it boost anything as well. So over here, if you see in Vampire Survivors, HP times level. Okay, this can be implemented if you go to the level boost over here and check health. This means that the enemy's health will grow together with your level. Or if you want the move speed to grow together with your level or damage or whatever, you can set them accordingly as well. Okay, but I think that will make the game pretty wacky, because if you multiply the move speed by your level, everything is just going to move very fast. Okay, so you can control what your level boosts and what your curse boosts. So the default values are the values that are in Vampire Survivors, but if you want curse to boost damage as well, you can just select damage here. And then whatever you set here will go into the code that is right here. Whatever you set here will go into the curse boost or level boost here. And then this will control what stats the curse operator boosts or what stats the level operator boosts. Okay, so once all of this is done and you have a way to boost the stats, you want to go over to recalculate stats and make some modifications as well, and these are the modifications. Okay, so you want to grab the curse and you want to grab the level as well. And then you just grab the base stats of the character, multiply by the curse value, and then multiply by the level value. And then this will cause the actual stat boost. So once you have implemented these codes, you can jump into your game and you can just adjust the curse stat of the character, and you will find that as you change the curse stat, the enemies will get stronger. So let me give you an example, alright? I'm just gonna start the game and the enemies are normal now, right? Why are the enemies so strong? I think the curse stats are boosting the enemies now, even though the player seems to have a curse stat of 1, the enemies seem to be very strong. So maybe I've made a mistake somewhere. Let me just check the bet over here and go to debug mode. So it seems like the curse stat is is boosting all the enemies, which is very strange. Because I haven't set the curse stat to do anything, you know. Bad curse boost. Should just be health and move speed. Speed. Why is the curse boosting everything? Enemies are all very strong now. It's so scary. Let's try this again. So you can see what the curse that kind of is working, but I have some code somewhere that is malfunctioning. That's why I'm getting this issue. Let me just check the curse value. Let me just print out the curse value, and from there we can see what's the issue with our code. Enemies are so strong now. So the curse value here is 2. I've got to figure out why it's 2. It shouldn't be 2. Maybe it's just because I have some code here that is malfunctioning. That's why. So it's 1 plus total curse. And it should, oh sorry, it shouldn't be 1 plus total curse, right? It should be just curse. Total curse. Okay, I made a mistake here. It should be just total curse. Okay, so now the enemies behave properly, behave normally. I've gotten the values correct now. So let me just show you what happens if I increase the curse stat. So if I increase the curse stat, you will see the enemies start getting stronger. So let me just kill some enemies, and you will see the new enemies that spawn become much more threatening. See that? Okay, you can't really see that now, right? Let me just kill some enemies and see if you can see how this works. I'm getting 0 gems. See that? So now new enemies that spawn are stronger because of the curse stat. So increasing the curse stat will cause stronger enemies to spawn. Okay, which can be pretty scary, right? So now we have a working curse stat, and that's pretty exciting. And the enemies are hard to kill as well. See that? And I also have a little bug here with the flower wall, because the flower wall is not supposed to spawn gems when they die. So if that happens to you, you want to go to your drop rate manager and make sure that it's set to inactive. Okay, very important, huh? Otherwise, enemies that die or despawn, they will actually drop objects. So make sure that active is unset for all of your enemies, so that the drop rate will so that when enemies die naturally without getting killed, they will not spawn any gems. So again, enemies are normal, they are going slow, but then once I increase the curse stat, you will see they start to get really scary. So here, let me just grow the curse stat to say 2.29. And then after that, see the enemies that appear after that just become really fast. See that? They have the red bat here and it's flying a lot faster. It's because the curse stat is higher. And mobs are very fast as well. So if I increase the curse stat further, you will see the enemies will get even crazier. So the curse stat is a very interesting way for us to adjust difficulty of our game. And if you have level boosts as well, right? If I were to set the level boost to, let's say, health, and what happens then is that now the higher my level, the more health enemies will have. So this is great for if you want to create enemies that are tied to your health. It's probably for the late game, you know, and if you play Vampire Survivors in the late game, you'll find enemies become really hard to kill. And this is because your level is really high. Okay, so now you have some very interesting modifiers to play around with to get your game and to get your enemies to become more dynamic. And let me just go and modify the article because I just made a change to the script for enemy stats, right? Sorry, not for the game manager. Because the script under the get cumulative curse is correct. Okay, this should be total curse. It's not 1 plus total curse. Okay, so if you're editing, so for my editor, just take note of this. For the get cumulative curse function, this shouldn't be a 1 plus total curse, this should be just total curse, alright? It's very important. So please include this in the video. Please use the right footage to when I'm describing the cumulative curse script, please use the right footage. Otherwise, you get 1 plus total curse. I don't want the viewers to copy the wrong thing. And we're almost done here. So now that we've gotten the curse boost and level boost to work, the last thing to do is to just test it out. Okay, so the article explains how all this works. You can get the stats and you can multiply the stats by 1.5 and this will boost our enemy stats by 1.5. If you get the stats and you do a up arrow here, this will boost everything by 1.5 as well, but it only works for stats that are marked to be boosted by level. So this multiplication and this arrow sign here, this only works together with the enemy setting. So you have to set the curse boost or level boost. So if you set this to nothing, for example, right, then even if you try to multiply the stats by curse or by level boost, you will not get any boosts. So the operator here is important, right? The operator that you use will control which setting is boosted. So whether it's by curse or by level. So the final thing that I want to implement on the curse manager as well, the spawn manager as well for curse is that notice that the curse will also affect the spawn interval of enemies. So for this, we can actually go over to the spawn manager and then let's add a checkbox here called boosted by curse. And if the spawn manager is boosted by the curse effect, then what we'll do is that we'll just modify the activate cooldown function. So previously the spawns are controlled by a spawn timer, so then whenever the spawn timer expires, we will just find a new spawn interval and then set it to the spawn timer. So instead of doing this, because we are doing this in multiple places, we will replace these functions with activate cooldown function, which does the same thing. It does the same thing except that now we take into account the curse boost as well. So if the boosted by curse checkbox is checked, then we will get cumulative curse. Otherwise, we'll set the value of the curse boost to 1 because anything multiplied by 1 doesn't change the value. And then we'll grab the same spawn interval, but we'll divide it by the curse boost. We'll divide it by the curse boost because, well, it's the formula that you see over here, right? Spawn interval divided by the curse. And this will give us a decrease in the spawn interval, which means enemies will spawn faster. Just a slight modification to implement the formula, the curse formula into the spawn manager as well. And we're almost done for this part. The last thing that you want to fix, right, is that if you look at enemies in our game, you will see that they don't sort themselves very well. You will see enemies that are supposed to be behind, they sometimes appear in front of each other instead. And to fix this, we can do a couple of things. Okay, what I'm going to do here is I'm going to create a new script called sortable. And this sortable only works when you have a sprite renderer. And what we're going to do is we're going to make this class abstract. Why we make this abstract is because we want to apply this retroactively to some of our classes instead of attaching this as a separate component. So what do I mean by that? So what I want to do is this sortable class, let me just create this sortable class inside our scripts folder. Okay, let me explain how this sortable class works as well. Okay, so this sortable class, you can enable it or disable it. And it's just going to be in the start function and it will find a sprite renderer. And then there's just a late update function over here. And what this late update function over here does is that basically it checks how far down you are on the screen. So the lower you are on the screen, the lower your Y value is going to be, right? And the lower your Y value, the higher your sorting order is going to be. So you will see here, basically, the sortable applies to anything with a sprite renderer. Okay, so anything with a sprite renderer, you can attach a sortable component to it. And this sortable component will take your position Y, the negative position, because the lower you are, the higher your sort order is going to be. So it's taking the reverse of your Y position and then divided by minimum distance. What this does is that basically the minimum distance here will affect, so for example, if enemies are, one enemy is lower than another by more than 0.2 units, it's going to try sorting it. So enemies that are very close to each other, we are not going to try to sort them. But enemies that are far away from each other, further than 0.2 units away from each other, we will try and sort them. And then basically we sort them in late update, and then we are just basically updating their sort order on the sprite renderer. Okay, so by doing this, right, you will find that enemies will automatically sort themselves. Instead of having the enemies that are higher up overlapping, you will find that after we implement this code, the enemies that are lower down will always appear higher than the enemies that are higher. So then we made this class abstract because how I wanted this class to be applied is, instead of attaching this component to our game objects, we are just going to find the scripts that we want to be affected by this component. So most of the time it's going to be the movement script. So I'm just going to replace mono behavior here with sortable, and then what this does is that this will apply all the codes that are sortable to enemy movement. And I also want to apply this to the player movement script as well. So the player also gets sorted according to how high up or how low down they are in the scene. So sortable, player movement is going to be sortable as well. And whatever that you make sortable, right, I'm going to make the pickup sortable as well, so that the pickups will also sort themselves. So let me just find the pickup script right here. And I will change the pickup script to be sortable as well. Okay, so once we have applied all of these changes, you will find that the pickups, the player character as well as the enemies, will have a couple of extra properties over here. So the player movement over here, you will find, where is player movement? Player movement, you will find there is a sorting active, and then there is a minimum distance as well, right? Because now we are able to get the player to sort himself with the rest of the objects in the scene as well. Where are the other where are the other values of the player movement script though? Why is this working like this? Okay, so one thing you have to take note of is that if you, after you inherit the sortable class over here, because sortable class has a start function, so then that means that under the player movement here, we will need to make this protected override as well. So same thing for the pickup script. If there is start function, we have to make this overridable. And we have to apply the same logic to enemy movement as well, where this is no longer virtual, this is override. And we also want to add a base.start to all of them. Base.start. And then finally here we also have a base. This is because, again, the sortable will use the start function to get the sprite renderer. So you have to make sure that the start function is added to all of them, the base.start. This is all, again, documented in the blog. Okay, you have to modify sortable on the existing scripts by adding the sortable class here, and then by changing the start function to have protected override. And in movement is the same thing, protected. This is no longer virtual, but this is override. And for the pickup script, same thing. This has to be protected override, and then you have to call base start. And all of them you have to call base.start as well, because the base.start function will activate the sortable script. So you might be wondering why didn't I just design the sortable as a component? And the reason for that is because if I design this as a component, it's going to be less efficient than if I design this as a part of a player movement script or a part of the enemy movement script or the pickup. And the reason for that is because if you have multiple components, it generally tends to slow down how fast Unity runs. So I'm just offering a different way to implement your sortable script. So for those of you who don't like to use subclassing, let's say you want to keep your player movement as a mono behavior, that's 100% okay. Just go to sortable and then remove the abstract class, and then this will allow you to attach the sortable as a component to your game objects. I just prefer to integrate sortable into our existing classes so that we have one less component to manage and to work around. So with this is all I have for part 22 over here. So once you have implemented this, you will find that enemies that are in the scene, they will always sort themselves automatically according to how far away they are from, or how high up they are in the map. So if I were to show you the flower wall now, let me just get a flower wall to spawn, and then we can see the effects of this. Let's wait for the flower wall to spawn, okay? I'm gonna set this to 25 and spawn, so that we will keep getting new spawns, and then we will see the flower wall fast. So there's a zombie mob here. Let's wait for another 10 seconds to get one more mob. Hopefully it'll be something else like a flower wall. So now we have the flower wall, and you'll see that no matter where you go, right, the flower wall will always have the correct sorting. And this is because we've added the sortable to it. So now you see they're very nicely overlapping one another in the correct way. And if you check them out, you will see the sorting layers are always done correctly. So in the enemy movement script, let's just go to debug. And let's check out the, sorry, it's not the debug, it's we can check this in the sprite renderer, right? So in the sprite renderer, the order and layer, this guy is 0. But then if we select something else, this guy is 11. And we select something else, this guy is 25. This is because the higher up you are, the lower your sorting order is gonna be. See that? It's extremely important. Yeah, otherwise if the sorting order is wrong, then you will get situations where you will have one flower appearing over another. Yeah, and the sortable layer, what it does is that it just makes sure the sorting is always correct. Depending on where the enemy is, sorting layer is always different, so that enemies that are above will never overlap the enemy that is below. So I hope you've enjoyed this part. This is I'm done with part 22. So we'll take the next week to edit the video, and we should be able to push it out by the end of next week. So as usual, thank you for your support. And yeah, I'm excited to create a buff and debuff system after this. So stay tuned for that. Oh, well, this is just a short stream so that I could do the recording for part 22. Thanks for dropping in. So I'm done with the stream. If you have any questions, you can always drop a message to me in the forums. Otherwise, I'm gonna go off and I'm gonna just start working on the rest of part 22, like the edits and stuff. Okay, thanks for your support. Thanks for dropping into the stream. I'll see you all tomorrow. Actually, tomorrow I'm doing another stream, so you can catch me there. So tomorrow the stream will last for the full 4 hours because it's just a generic coding stream, and I'm gonna chart out what we can do to move forward with the Metroidvania series. Okay, so I'll see you all tomorrow.